Hi guys, so this is probably going to end up being a longish video that has several different pieces. So I thought that I would start with sort of an overview of the project, but then also an overview of what we do for checking exactly how we go about it. And then I'll do at the end a walkthrough of exactly what to do. So what are we doing? You're helping me identify YSO candidates in this region, ic1396. Why? Well, I have time series data. In other words, I've watched this part of the sky many times over 40 days, and I can see how the objects change brightness with time in two bands, IRAC1 and IRAC2, which is roughly 3.5 and 4.5 microns. In order to interpret these light curves, I need to know which ones are young. I need to know if the thing that I'm seeing varying is a quasar or the thing I'm seeing varying is a young star. I need to know if it's a galaxy, if it's not a galaxy. I want to know what fraction of young stars are variable. I can do the numerator of that ratio because I can identify which ones are variable. But what do I put in the denominator? How many YSOs are in this region? And in order to do this, you need to check each and every object because the computer has just done simple position matches. It has not done anything sophisticated at all. And just because the computer says it doesn't mean it's right. In other words, count your change, right? So here, what I'm trying to figure out is there really a source there or is it an artifact? Is there really more than one source there? Is it a galaxy? Does it, does the SED look like a young star? All of these things is what I need you to work on. So the mechanics of it is you need to look at both the SEDs and the images. For the images, do the images look okay? Does the image look like a point source, or is it actually an artifact or even a galaxy? Is the source matched correctly across the wavelengths? Is there more than one counterpart at a particular wavelength? Because you're working with images that have much different spatial resolutions. The other thing that you need to look at is, does the SED look physical and realistic? Does it have all the data included that it should? In other words, if you see a two-mass counterpart in the image, but there isn't one in the SED, or that there's two-mass points in the SED and there isn't one in the image, does the SED only have two bands, in which case you really can't do much with it? Does the SED look okay in the IR but the optical is wrong? It's still a perfectly fine YSO if that's the case, and you shouldn't throw it out. Is there disagreement if at any given band? In those cases, take the higher spatial resolution measurements and let me know what measurements should be thrown out. So for the SEDs, you made some SEDs and I made some SEDs. I think we're working from the same original source catalog, so our SEDs should be the same, and it shouldn't matter whether you're using mine or your SEDs. For the images, in practice, you probably are going to use more than one tool because there's not just one tool that can talk to every single one of the images directly that we have. So what I recommend that you do is primarily use Finder Chart. You use the Spitzer Heritage Archive when you need to and DS9 when you have to. I have had some people have trouble using those things, in which case you need to use DS9 for the whole thing, not just Finder Chart, but DS9. So for a real life example, of course, Spitzer and Wise and Herschel see through lots and lots of dust. So you can easily see galaxies even when you're not trying. So when you're looking for star formation, it has similar colors, whether it's here or kiloparsecs or even megaparsecs away, it has the same colors. So we need to figure out what's a local object, what's a cluster member, and what's a galaxy. There's a wiki page on finding cluster members, which has lots and lots of information, including multi-wavelength observation at other bands. But again, what we're doing here is looking at images and SEDs at a whole bunch of wavelengths, especially in the optical, because that defines the short wavelength or the Veen side of the SED. The infrared is defining the Rayleigh-Jeans side of the SED. And higher spatial resolution is great because then you can tell if it's a galaxy or not. So for a real life example in Taurus, I have Spitzer and Wise data as well as a whole bunch of other data from X-rays to radio in the Taurus molecular cloud. So those are the two references from where I use Spitzer and Wise to look for young stars just like you're doing now. The optical imaging that we had when we did this turned out to be absolutely critical for assessing whether or not something was really a young star, which is why you're doing this. So in the context of doing that, we needed to assemble the SEDs and look at the SEDs as well as the images, and we threw out a ton of stuff. So here's a real life example. It has observations at MIPS 1 and 2, so 24 and 70 microns. And from this image, it sure looks like a point source, and it's got the right colors to be a young star. So then, okay, what does it look like at IRAC bands? Those are IRAC 1, 2, 3, and 4. And I realize that you don't have a calibrated IRAC eyeball yet. You will. But that source is distinctly not circular, even at IRAC bands. And when you look at it with Sloan, indeed, it's a galaxy. So Sloan is relatively high spatial resolution in the optical, and you can see that it's not a point source, it's a galaxy. Here's another example where it was a point source at MIPS 24 and 70, and IRAC 1, 2, 3, and 4. Again, you can start to see it's probably not a point source, and then of course when you look at it with higher spatial resolution, it's a beautiful star-forming galaxy. Just not something we care to study, so it goes in the garbage bin. Here's another example at Ys. At 1, 2, 3, and 4, the Y spatial resolution is very poor, and it gets worse the longer wavelengths you go because the telescope isn't changing size. So this is the same chunk of sky, and it's still a circular source at all those bands. You go and look at 2 mass. Okay, I have a calibrated eyeball, but that looks relatively circular. At POS, maybe you can see some extension, and at Sloan, yep, it's a galaxy. It's a star-forming galaxy. So this is the kind of thing that can trip you up. These are some nice SEDs from that Taurus paper, and you can see we've got multi-wavelength SEDs. So here we had optical, Sloan, CFHT is also optical data. Then we have 2 mass data, Akari, Ys, IRAC, and MIPS all together. And these are some nice SEDs. They look just like, you know, pictures from a textbook on what an SED should look like. These are not nice SEDs. We've got things that don't agree. The fluxes don't agree even at the same bands. We've got things that are super duper flat. We've got things that, you know, sort of turn over but not really. And we've got things that are sort of missing data. And this one is just really, really flat. So these are all SEDs that we put in the I don't think so bin. In the cases where the points don't agree, it could be an extended source. The source may not be matched appropriately, and that's what you're looking for, right? So you can help me identify the ones that aren't matched correctly. And by looking at the SEDs, you can say, okay, these are gorgeous, likely YSO SEDs. These probably not, or certainly less confident things for which you're going to need a spectrum before you can identify what they are. So this is the last step of the process. After you look at the images and the SEDs, you can make some color and color magnitude diagrams. So this is Ys1 versus Ys1 minus Ys4. So 3.5 minus 22 microns versus 3.5 microns. And everything that is a plus was a previously known young star. So you can see that they are generally bright and red. The circles are the ones that hung on through the SED and image checking. The red X's are everything we threw out. So we threw out a ton of stuff in this region. Now, your situation is going to be a little bit different because you have a much smaller field of view. This was more than 100 square degrees. And this one was not in the galactic plane. Since we're working in the galactic plane, the galaxy interlopers are likely to be much less, but we may have foreground stars, background stars, things that are not likely to be truly members of the cluster and truly young. So the very first thing you want to start with is you want to start a spreadsheet so you can keep your notes. I recommend, because I get screwed up by this all the time, the source number is not the same as the row number because you can put headers at the top of the column. So that has bit me in the butt more times than I can count. So I would recommend coloring the source number column differently than the row numbers that you recognize. You're always looking for, say, the purple column that has the source number. I recommend that you keep a place that has space for long form notes. I think this, I don't think that, I need help with this is okay, this is not okay. But then also have a column that is a terse summary of what you think. This is okay, this needs help, I need help understanding it, you know, or this is not a young star. So that someone who is looking at the SED and trying to merge opinions from all of you has a sense of your bottom line conclusion about the source. So the first approach I'm recommending is identify the file with the SEDs that you're using. I'm going to use mine. You will need to find the IPAC table file format list of sources that I gave you. You need to upload that IPAC table file to Finder Chart so you can get chunks of the sky for all of these positions at once. Then you want to scroll through and look at the finder chart images and the SEDs together. Make sure everything looks okay and take notes. Make sure you're taking notes in the right line. If you were assigned to start at source number 50, then you should be working at source number 50, not the first source in the file. If you have to, if the finder chart is not clear enough, if the SED looks weird, you want to load the Spitzer Heritage archive and search for your target over a small region. You should go and get the SEIP, mosaics, and source lists. That's the most efficient way to check this, even if it's not exactly the same data that I used to create those SEDs. It'll at least give you a sense of whether the source is an artifact on the edge of a mosaic, hit by saturation, all that stuff. So you can actually look at the images. And if you still need more checking for this source, then you can go on to the second approach. For the second approach, you need to get big mosaics of the region. In order to do that, you need to get the target center out of the data paper. Use Finder Chart to get big images of the sky from POS and WISE. You're going to need to use Skyview for 2-mass because the 2-mass mosaics are only stored in tiny tiles. And so even if you're trying to use Finder Chart to get a big chunk of sky, you get a lot of empty no data regions, so you need to use Skyview to get 2-mass. You can use the SHA to get the Spitzer images. You can get the IFAS images directly from the IFAS archive, and then you can load them all into DS9 all at once. Load the regions file with our list of targets on top of that, of all those images. Find the image you want to check, align everything north up to that same chunk of sky, and then inspect the images over all of the bands that we have. So at the end, what we need is one big spreadsheet in which all of you agree that what category the sources should have. So just coming out of thin air, these are the 6 categories I came up with. You may need 7, you may need 8. I don't recommend 20. Maybe you only need 3. But these are the ones I came up with off the top of my head this morning. You can have a great YSO candidate. It's got a fully populated SED. The images look great. The SED looks great. Fabulous. It can be just an okay one where it's pretty well populated SED, it looks pretty good. There's ones where, something is weird. It needs some work. I missed a match in the catalog I gave you, or I made a match I shouldn't have, and there needs to be some changes to the catalog and the SEDs. Could be also a, I'm not sure what's going on. It's not really circular, could be circular. It's hard to tell what's going on. And then, I put did not finish, DNF, for lack of a better term, in those situations where you only really have data at 2 bands. And so you can't really tell what's going on because there's not enough information. And then the last category would be complete trash, something that's clearly an artifact or clearly a galaxy. If you have time, maybe even after the AAS in the spring, what you can do is that last step. You can make optical and IR color and color magnitude diagrams where you take, in this case, the 6 categories and make the points different colors in the diagrams according to those different bins. And then look at where you've put the better quality objects. And you can tell from where they fall in the color magnitude and color diagrams whether or not they're likely young stars or likely not. Because, where they fall in those diagrams could either support or undermine the case for them being young stars. So let's get started on this approach, okay? We're going to find some SEDs, we're going to find the IPAC table file format, and we're going to upload it to Find Your Chart, and we'll do look at a few together. I'm going to leave it to you to take notes and make the spreadsheet. I'm going to show you a spreadsheet from my current team that has exactly this. Okay, so if we go and look at, because I have access to the stuff from my current team, but you don't, let me just show you the list of interesting sources that they've been working with. So we have here at the top, row number. See, it's purple, so that I remember that the row number is not the same as the source number is not the same as the spreadsheet row number. The phone number, the catalog number, so that we can make sure we're working with the same source. Why the source is here, who is making the notes, my long form notes that talked about, okay, in this case, there's no infrared points other than IREC 1 and 2, but I can see it in WISE. Where did the counterpart go? WISE counterpart should be this source. And then I went and looked at what I'd done and was like, oh, I didn't search in WISE out far enough. So now the SED has WISE added to it. So the terse summary might originally have been needs help, but it is now okay because it got the help that it needed. Okay, so that's the kind of spreadsheet that we've been working with and that I recommend that you guys work with. What I would like in the end is one assessment that is what all of you agree on. Not, please don't give me like 25 different assessments for each source. Please give me just the summary assessment for each source. Okay, so let me go find the SEDs and things for you. So I have just the SEDs here. So this is the catalog that I had given you guys. So this one is the short catalog that just has the source number, the IAU compliant position-based name, the RA deck, and why the source is here. So that if we drop it on a text editor, that doesn't even have the row number, I'm sorry. It just has the object name, right ascension declination, and why the object is here. So if we go to find your chart, what we want to do is not search on a single position, but search on multiple positions. We want to go find where the source is on my disk. So for me, I have it for you here. Okay, so then I recommend probably smaller rather than larger. You can choose which images you want. I don't think there's Sloan data, but let's look. We do want it to search the corresponding catalog, but you may need to ask it to search over a slightly larger radius. So let's see what it comes up with. Did it find any Sloan data? No Sloan data. Okay, so that you can now turn off Sloan when you go to search. So let's go back and do that so that you can see exactly how to do it. Turn off Sloan. Okay, so now it's going to load in here. Here's the source number. Here's the object name, right ascension declination, and why the source was selected. It's going to load in the images, the same patch of sky. So there's DSS, there's 2MASS, there's WISE. It's also slowly chugging away and loading the 2MASS catalog for the region and the WISE catalog for the region. So the way that this works is this is row 1 that we asked it for, and it found 2 sources within 15 arcseconds of that position, and it found let's see, 2 WISE sources within that position. So for reasons passing understanding, I have a bug that very few other people can reproduce, whereby it only sometimes overlays the catalog on the image. Here it has successfully done it. It has put in, you can see there's the red source. If I move my mouse, the scroll bar will show back up, but you can see there's an orange point right below my cursor there, and then there's the source that we're actually searching on. So this was the 2 sources it found for WISE. Those are the 2 sources it found for 2MASS. If you run into the bug where it doesn't overlay the catalog, if you click in the image, it should jump to that source in the list. So if you click in the image, it will force it to actually check that there's a catalog there and actually draw the source on the image. Same thing for WISE. Yeah, so there's the 2 sources. So if I click there, it highlights. Okay, so in this particular case, you can see that the DSS images look pretty good. This one is a little bit offset, but it's, you know, also got bigger pixels. All the rest of them look okay. That one looks like a nice circular point source, well detected. WISE 1 and 2, very well detected. Really nothing there. 3 and 4. So let's go look at the SED. It's got some optical points. It's got 3 2MASS points. It's got 3 but not 4 WISE points, and it's got 1 IRAC point. So it probably has no IRAC 4. That I think is IRAC 3. So that's kind of strange that there's no source in the image, but there's an IRAC 3. In this particular case, it actually looks believable because it's kind of lined up with the rest of the sources. So let's see if we go over here and make sure that that's the source we're looking at for WISE. Let's scroll over and see what's going on. WISE 2, WISE 3, so it's got a detection for WISE 3, and it has a limit at WISE 4. See, AABU, U is upper limit. So the upper limit is actually missing from this plot. So that's something that you should tell me. So in your spreadsheet, you should say, I don't see the source in, you know, I see the source just fine in 2MASS. I see the source in WISE 1 and 2. I don't think it's there in WISE 3, but the point is consistent with the rest of the SD. Let's let it go. And there should be a WISE 4 limit, but there isn't. So tell me that. Put it in the spreadsheet. Let me know. As far as, you know, this seems to be a perfectly valid young star. It's here because it's variable. So you don't expect an infrared excess because it's here for variable reasons. So it looks good. So you can scroll through the rest doing exactly that. Let's check, since this source doesn't seem to have been detected in the Spitzer data, because I only have the one Spitzer point, let's check what's going on there. If we copy from here the object name, the position-based name, let's go over to the Spitzer Heritage Archive. We can put in here J and then the source we're doing. If you put in J first, then it understands that what you're about to give it is a position-based name, and it will resolve it. Let's change this to only 10 arc seconds, and let's make sure that we ask for the SEIP supermosaics and source list. So it's going to go off and get that information. Okay, so it found a whole bunch of observations, but if we go straight to the supermosaics tab, it should only give us the supermosaics that are closest to the position that we care about. And this right here is the tile number. You can see it's all the same tile. So if we sort by clicking on file name, you can see it puts it in alphabetical order. Here are the short exposures for Iraq. We probably don't want those. There's a couple different versions of Iraq and a couple versions of MIPS 1. So if you go over here to data, let's get the long Iraq 1 exposure, and there's our source. So we can zoom in and keeping our source in the center. Let's keep zooming and keep zooming. Yes, I know, can't go any further. All right, well, there's clearly a source there. Looking at the other point sources, they don't look very circular, but that's okay. Iraq doesn't have a circular PSF, it actually has a triangular one. And this source seems to be right on top. So if we do the same thing, if we go make the image big, and let's see, zoom in several times. Let's see if we can actually make this work the way it's supposed to. Ah, it didn't. Okay, so you can look for it there. But let's go see if we can find it in the other frames as well. Let's go look in the Iraq 4 frame, because I don't have any 8 micron data here, and that could be really useful. Let's see what's going on. Yeah, I don't know, man. It might be there. If we do a different stretch, we might see it. What's interesting is that it has actually put an SEIP source in there too. So if I go to the source list, there's only the one source there. And so let's see if SEIP has an Iraq 4 measurement. Let's go keep crawling over. There's Iraq 1, Iraq 2, Iraq 3 doesn't have anything, Iraq 4 does have something. So that's something else to tell me in the spreadsheet. There should be Iraq data at all 4 bands for this source. And you can even tell me, I think that it should be matched to that source. So if you select it, copy, paste it in the spreadsheet saying you should have matched it to this source. That will help me a lot when I go to implement the changes that you've suggested, because you've already done the matching for me. And then we can add those points into the SED. I have no idea why they're not there now, but they should be. They should be in there. So if, you know, that's the basic idea. What if the source that you're looking at needs more checking? What if you need to get additional information? So let's implement the second option. So if you go to the box drive and go and get the original data paper, what we want is the center of the field for 1396. So we go down, and here's the center of the field for the ic1396 data, for the data that you're working with. Okay, so if you select it, copy and paste it. Let's go back over to Finder Chart. This time we're going to search not on multiple positions, but just a single position. And we're going to go over, let's see, I don't remember how big the field is. Let's go back to that data paper, and it will tell us how big the field is. Let's see, box cadence notes. Okay, so it says 2 by 3 Iraq FOVs. So each one is 5 arc minutes. So if we do 20 arc minutes, we should catch everything we need. Let's hedge our bets and do 30 arc minutes. Okay, we already know there's no Sloan data. In this case, we don't need it to search the corresponding catalog search. So it's going to come back with a relatively big field of view for DSS. Now for 2MAS, remember, 2MAS is stored in tiny tiles, and so you see most of the image is black, so that's not helpful. The WISE data, though, are nice. So we go ahead and click download and say, yes, I want the fits. You don't need reprojected. Go tell it to start preparing that data. for SHA, let's go search on the center position. And then this time, yeah, let's do 20 arc minutes. Okay. In this case, we do want the super mosaics. We don't need the source list. Don't even need that. Let's go search, and it will come back with all the super mosaics that it finds within 20 arc minutes of this position. So while that's thinking, let's go over to Skyview. Skyview, note that it's at Goddard. Let's put in the coordinates of the center of the field, and what we want is we want 2mass, because the tiles are too tiny at Finder Chart. So we can get the IR images from all of those things, all of those places. You could, if you wanted, see what other data are out there, but for now I'm just going to demonstrate that. Now what we want is something the same size as what we were just asking for. So if I go back over to a spreadsheet to do the math, let's see, the Skyview wants it in degrees. So what I want is 30 arc minutes in degrees, and there's 60 degrees. There's 60 arc minutes in a degree. So what I want is half a degree. So don't save that. Let's go here. I want 0.5 degrees. Now, Skyview is a little bit tricky. It will happily do this to whatever pixel size you want. But what we want is the default. We want not the default 300 pixels, but we want the original 2mass default pixel size. So let's see if we just delete that pixel size and just put in the degrees. Let's see if that will work. Let's see what it gives us. Now, because it too is working with these tiny 2mass patches of sky, these might come back looking like patchwork quilts. Let's see. Okay, so it did take the default image pixels. We want many more than 300 pixels. Let's go back to the query form and let's put in, you probably should do the math. So let's get the spreadsheet back up here where I was just doing the math before. The default 2mass pixels, I believe, are an arc second, and what we want is 30 arc minutes. So if we do 30 arc minutes times 60 arc seconds in a minute times, I think it's 1.5 arc seconds per pixel for 2mass, we should check, but I get 2700 pixels. So let's put in 3000 pixels, submit request. Get rid of my little calculator there, and it's going to drop, note that it's going to drop the results in that same spawned tab that it had before. Now it has much bigger images. It's going to take a little while to get it. This is J, I'm pretty sure. Yep, this says the top 2mass J. So to save that image, what you want is the fits image. So get it, save it, and it's going to do the same thing for H. Save it, and K, save it. Okay, so it has saved it using file names that make sense to it, but it is a computer. So we're going to give it a chance to download, then we're going to change that into something meaningful. So for me, I might put ic1396-J. Let's give it a chance to finish loading. Let's come over here. This one says that it's done, so let's download those. And let's see what the SHA came back with. There's the super mosaics. It found 124 super mosaics. So it's got all of the long, short, IRAC, and the mosaics combined in different ways. Click that to select the top, prepare download, and let's ask it. That's okay. It'll be quick. So it's going to package those up. Let's go back over here, see if it's still downloading. So it finished Finder Chart, and it's almost done with the Skyview ones. All right, so let's create a directory into which we can start putting these things. So ic1396 big images. All right, so this one, it's not done with 3 yet. That's odd. Let's check. Okay, so this one should be ic1396J. And this one should be ic1396K. This one, I don't know why the file name didn't get fixed. ic1396 sorry, this one was k.fits. K short. No, hang on. Yeah, we want to use fits. But was this one, I think this one was H. Let's check. We should check. Let's see if we drop this. If we drop this onto a text editor, the binary stuff is at the bottom, but we can at least look at what the header says. This one says, let's see what band it is. That one's H, so I did get it right. That's H. Okay, so we have JH and K, and then so let's move those JH and K into the big images directory. Let's go look at the Finder chart files that are in here. So it gave us 2 mass images, but we already know that they're too small. It's going to give us the WISE ones, and the DSS ones are the ones that we want. We don't, yeah, okay. And let's bring those into the ic1396 big images directory, and then we can change the position here, the name here too. We can put ic1396 DSS1 fits, you know, get the idea. Change all of them so that they have file names that are meaningful for you. 1396 ic1396 ic1396 ic1396. Okay, ic1396 ic1396. I make it all formatted the same. Come on. ic1396 and ic1396. All right, let's go see how the other things are doing. We can throw out these files because we've already unpacked them and we don't need the 2 mask small fields of view. Let's go see how SHA is doing. Okay, so, whoa, okay, it's got a lot of files. Maybe what I should do is download these for you and unpack them into pieces. Let me add my email so that I get all the links. So what I will do is I will try to get these for you and then just put the 1 mosaic per band per tile in the box drive for you, so you don't have to download all of those yourself. But then you should put those in your big images directory too, with it labeled IRAC 1, IRAC 2, IRAC 3, IRAC 4, okay? And MIPS. So then the last thing is if you want the IFAS data, let's search in the IFAS data too, search. And so it doesn't give you a search radius. You just have to sort of take what it gives you, but it should cover our region. I don't think it might not cover the whole region. You might have to put in slightly different positions to get what you need. It found 15 images, so RI and H alpha in several different tiles. And so similarly here, you go and grab the FITS file and save it, and then you have to rename it into something that makes sense to you to indicate this is, you know, tile 3. I guess there's 2. So you make a name that makes sense for you for H alpha, R and I for these various things, and you can load them in, and you can save them to disk. So let's let the Spitzer data keep chugging, and if I go, and so I'll put those data where you can get it, and then when you want to collect them all in one place, then what you can do, so I had it all in an ic1396 big images directory. I have a Unix machine, so I'm going to get rid of the executable status of these things. So because I can work from the command line, I can do ds9 star.fits. You may want to do something similar. There's a video in my YouTube feed that talks about how to do this on Windows machines. You might want to do it in wavelength order because I find that useful. So in that case, you want to put DSS red fits, red, DSS2 red, DSS2 blue, DSSIR. Then you want, whoops, blue should have been in there. Let's go back to the beginning. Put in blue, and then go back to the end and put in J, H, K, WISE1, WISE2, WISE3, WISE4, and then if you had Spitzer, you'd put those in there too. So then we can load it into DS9. Whoa, why did it crash? Fun. Okay, let's do something, see if DS9 by itself will load. All right, so there was something wrong with one of those images. Let's try DS9. let's see, ic1396J. Let's see if that works. Okay, so then you can do frame, new, file, open. Let's get H, frame, new. Oh, maybe H is the problem. Oh yeah, because remember it said it didn't finish downloading, and I thought that maybe it had. So let's go back over here to Skyview and get H to download properly. Oh, there's something screwy with H. That's the problem. Okay, so you may need to search again and see if you can get a better H. Let's pull into here. Let's just overwrite it in the maybe K is also the problem. K is the problem. Okay, so let's get the long list and get rid of H and K, because I don't know what's going on with those. You may need to try to download them again. Maybe I didn't wait until J was downloaded before I loaded the other ones. You may have to play a little bit. So it's loaded all of the images in to DS9 for us. Let's go and get the regions file that I made you. If I go back to, let's see where I can go to get my copy of the box drive, 1396 catalogs region, load into all the frames. Okay, so those are all of the images of interest, or all the objects of interest. I thought I had made you one that had the names next to them. Let me add that to my list of things to do for you. So if I do frame single, there's all the sources of interest. So let's say that we are most interested right now in this source here. There's two sources apparently that are right close to each other. So if we zoom in really, well, let's do this one because it's easier. There's a bright source there. Okay, then we do frame match frame WCS, and then frame tile. So now it has aligned all of the images that we've loaded on the same chunk of sky in the same direction. Now it doesn't do anything about the stretch. So in these regions, the stretch is clearly not right. So let's go change the stretch. Let's maybe make this, no, we gotta go the other way. If we put it down, if this one is at 100 and this one is at 300, let's see if that helps. Nope. 300, 400. All right, 300. So you see we're kind of in this blown out region. Let's try 350. No. So you'll have to play with it a little bit, see what works in order to pull out the source that is probably there. I might see it there. And in this band too, this is Y is 4, I think. Come on. That one I think is, yeah, Y is 3 and 4. So if we go look at it single and zoom out, you can see it's really bright, and there may or may not be a source there. But you have you can already get Y's tiles from Finder Chart, so getting Y's in here is less critical than getting, say, Spitzer and IFAS in here. So if we go back to tile, you can see that that fainter source that's to the left, to the east, not west, but to the east, is there, but in all those bands, but not in Y's. But that source is boomingly bright in Y's 1 and 2. But the sources are far enough apart that Y should not have confused them. Y should be able to resolve that. So you can see that the source is cleanly detected in Y's 1 and 2, but not necessarily have to play with it in Y's 3 and 4. And this source is not detected in Y's 1 and 2. So you can do the same technique with as many images as you can get your hands on. Load them in, take a look. Once I get you the one that has the labels next to it, it'll be a little bit easier, but still really tough to do it this way, because remember, it's a big region and we've got lots of sources, so this is already crowded, and once I add in labels it becomes even more crowded. But all of these sources are the ones in the list. You just have to identify them by position at this point, and I'll make a separate regions file for you that does have the names. But that's basically the idea. I would say go for Finder Chart first because it's easier to scroll through. Don't forget to overlay catalogs, check and see if sources are resolved, and then if you need to, retreat to the DS9 version of things. What I need to do for you is I need to get you the Spitzer data cleaned up in a place where you can get to it, and I need to get you the regions file with names so that it becomes a little bit easier to do the DS9 inspection. So I will do that.